now. Can you see the screen? You see the screen. And yeah, this needs to go here. Yeah. Screen. Great. Okay, so we have two colleagues here, Rafael and Antonio from Keysight, and they will do their presentation. So thank you, ready.
Thank you so much, UCD and NetLabs for inviting us. This is Antonio Sanchez from Keysight, my colleague Rafael also from Keysight. He's based in Belgium, I'm in Spain. We are 6G R&D security engineers for a long. We started with security a long time ago. And today we are going to explain or to put some basics about how a rogue-based station could compromise the security of a UE. Okay. First of all, we are going to explain some agreements, some basics that to understand the situation. For most of you maybe are familiar, but for some other maybe not. So what you have in your hand, your phone, has a modem which connects to the network side, but this modem doesn't work by itself. It is controlled by a modem controller, which is in the operating system. And the modem controller communicates with the modem through AT commands. So this communication needs to be almost bidirectional. The modem controller asks to the modem and responds and so on. Of course, this modem connects to the base station, to the network, all the things, and send data and those things. This is important to know because many people know that the phone is the phone and just that has different layers. The modem is in charge of all the lower layers, all the things that happens in the network, and the modem controllers just ask and response and get the response. For instance, this is an example of the commands that the modem controller sends to the modem, which are it calls AT command. Most of you know them. But for instance, this is to get the networks or the cells that are around the mobile phone or the modem. And you can connect to the network. You can request some other cells. Here, we have some examples, but this is just an example. For each modem, we have a lot of AT commands to do a lot of things. It's not just to connect, disconnect. We can do a lot of things, even to send messages or to any other commands specific for a specific modem. This is an example because we will use later for the demo. Okay. And also here we have an example of we have two things here. First one in the right side, yes, in the right side, we have the 5G state machine. It's important to know because in 5G or in 4G, even in 6G will be, the status of the modem and the network is based on a machine state. So the messages that the modem or the UE sends to the base station depends on the previous state that they have. So this is important to know because it depends the number of messages that you can send and receive from the base station. Here at the bottom of the slides, we have just an example of the uplink messages. Uplink messages are when we send the message from the UE to the base station, and the downlink messages are the vice versa, from the base station to the UE, to the modem. Here is an example on RRC command message. And in the left side, you can see the stack protocol for all the protocols on the 4G and 5G. 6G will be similar to 5G with some changes. We will see. One important thing is that the messages at lower layers are composed by tons of parameters. You cannot imagine. It's so huge. The messages are huge in numbers in terms of representation because it contains a lot of information. For the physical layer, is crazy. Also, we need to differentiate, or we want to differentiate three different kind of base station. The legitimate one, which is in green, representing in green, is the normal base station, which is operated by a normal operator, well configured, everything is working fine. This is a normal scenario. A rogue base station, which is could be it's a legitimate base station, but could be infected by a malware or compromised by an attacker, or even misconfigure. If you misconfigure a base station, the behavior could be like a rogue base station. And the last one is a fake base station or false base station. That is some malicious base station. Somebody put that base station, that cell there. And well, it's important to mention that this fake base station doesn't have the keys or the information to authenticate the UE. At the end, of course, many of you know, but some people not. The UE and the base station registered with some keys that are shared and some agreements. It's a very long story. But this fake base station doesn't have those keys, and they cannot authenticate the UE. Okay, that is the difference between those three false or base station status. The rogue base station can have these keys, okay, or should have these keys, those keys. Well, here is just an example. What's happened? We have in the left side the main device or the main controller or the modem controller that we talked before. The modem is the modem, the part of the radio that you have in the UE. Here in the middle we have the 80 commands, and in the right side we have the rogue base station or the fake base station that could be compromised with a malware. Okay, what's happened if the rogue base station or the fake base station send messages to the UE, to the modem, which are not according to the specification or are not expected by the modem? That's it. That is the point. What's the modem do? So the modem, what we see in our experiments is that the modem crash or at least is moved to a wrong state. Do you remember the state machine? So it moves to a wrong state. And in some cases, or most of them, the application or the controller cannot connect to the modem through 80 commands, or is stopped to work properly, or start to do wrong things or not good things, mainly. So that is the key point or the way to discover these problems. And you can think, okay, you are talking this, but this is theoretical, or no, this is not theory. It's real. There is some public information it's true. There are several projects and some research that are bringing public about exploits in 4G and 5G to the UE side, and which are limited because, well, the knowledge and the hardware limitations, but are real. And well, we have here a lot of public examples of devices. I don't know if you can see the graph here. Maybe it's too small, but there is a total number of smartphone models are 714. So it's, and this is not, of course, 100% accurate, but it's just a big number for a public. It's public information, okay? So this is this kind of things are those are the numbers. So one important thing that we want to mention and we rediscover is that after the responsive disclosure, some vendors didn't respond, didn't say anything. They don't respond. They just ignore the problem. We don't know if they ignore the problem or they just say, okay, this is a problem for the future. we will solve later in the next generation, or I don't know exactly, but it's interesting. Some others, of course, respond to the problem, but it's a good point to remark. When even not only in 4G, 5G, 6G will be, but also in general in IT, I suffered this kind of ignoration from vendors many times when we report something and say, it's not my problem. But this is not true. So I think this is yours, yeah. Right? Yeah. Okay.
Just move.
Yeah. So
Close to the microphone. Then I would invite you to think about first the kind of attacks that those devices are susceptible to. Basically are classical techniques or attacks techniques that we have, denial of services, main in the middle, and also the downgrade. So by using most of the time, only a fake base station, not really need a rogue base station with some information of the UE, that the targeted UE, you can replicate some of those attacks. Then I would like to invite you to think a bit about the 6G and beyond 5G use cases that would rely on the mobile communication. Again, the focus of our research is the downlink. So it means that we are attacking the UE, and then it will provoke basically a denial of service if it's crashing, or if it's, as Antonio mentioned, if the attack put the network, the UE, in a condition that it cannot be recovered. Then you talk about a bit of, in a high level, of our framework that we have in our testing lab to exploit or to find exploits for the UEs. We use basically a fuzzing technique. And the fuzzer technique, we can have the open box or the closed box or even the gray box. And we exercise all of them. And it depends a bit on the kind of information that we get from the device, basically. But the most common one that we can have, since we cannot instrument commercial devices or the firmware of commercial devices, we use it to work more with the gray box. And then we use grammar-based technique basically to understand what is happening inside the UE. The open box, we exercise most of the time with open source implementation, because we want to analyze the different strategies that we have. So then by instrument the code, we can have a better view about how many branches our seed can access inside the UE execution. And then after that, I would say that it's quite simple. We create a malformed packet, and then we send to the target, to the UE, and then we observe. We can observe via AT command or some side channel way to get the information, like the availability of the AT command, or even the consumption of the power consumption of the device, that are just some. And then we save it in order to validate it again, to work as an exploit. Here's one of the layers that we intercept. We use it to intercept most of the layers, but the most promisor would be the RRC, PDCP, and MAC. This is our results on our laboratory that we tested. Now it's a bit higher, 12 devices, but at that point we succeeded to test 10 devices and have more acquired data for 10 devices. And 8% of them has at least one vulnerability, with the worst one having 33 vulnerabilities inside that. As Antonio mentioned before, we report by representing Keysight. Of course, we cannot request for price or anything else than support them to basically fix the issues. But again, it seems to be not easy. Another thing to highlight here is most of the attacks happens during the RRC setup connection. During the RRC setup means that no SIM card information or even no authentication is required. If you have one device with the chipset, it's quite easy to exploit, just raising the fake base station and then put your device in a fault mode. Then I will explain a short demo that we have on our database, basically. So I'm starting a benign base station that we call on our setup. And I put the UE inside this shielded enclosure. And then I started the attach procedure via the AT command, as Antonio mentioned here. And then it started the attach procedure. I wait for complete that. And then I command the modem. I act as an application to consume the data, the internet data at this moment. And then we see some logs popping up on the benign base station that we have. And now I start the exploit mode, the fake base station and the exploit that we had found before. And then we are going to start the service of the fake base station that is on the right side. Is this one? Then we wait a bit to the modem search for a new connection. And then we have a crash in the serial interface, the AT command interface. Naturally, the UEs tries to attach to the base station that has a stronger signal. They are designed for that. This radio handshake of the state machine is designed for availability. So if you have a fake base station with a stronger signal, then it will try to attach, and then we can exploit it basically. Then some conclusions. First, the modern controller lacks context to distinguish what is the normal behavior from the UE and what is a crash. It's missing a layer in the application, a security layer in the application to understand the health of the modem. And this part doesn't exist in most of the modem. Just close it. Then the bug, as I mentioned before, the bug severity is higher as much as we can exploit the initial messages. And it's a higher number of exploits that we find, what is critical. And the time to react, as Antonio mentioned, is also very slow, even by integrator or even by the chipset manufacturer.
Yeah, one important thing to mention here is that maybe the chipset vendor is not the same as integrator, for instance. Yes, normal names that would appear in any conversation. Qualcomm is sell the same modem to several vendors like LG. Maybe I don't know the numbers, but LG or any other mobiles vendor. So when we found a problem or in a modem, it applies to several devices, not just to one device. It applies to the devices which has this modem installed. Yep. That is the small difference.
Okay. Then last, what we can see as a possible solutions that can enforce the security. First is the active monitoring. How to monitor the application or the firmware inside the chipset, or even how to monitor the environment around the UE that the UE is trying to connect. One thing that could help is the verticals. When you start to discuss about the verticals, then it needs to be designed at the security level in a way that if you consume critical data via 5G, it needs to have some redundancy or some way to recover the communication. And then, of course, software testing and quality controls, and apply security by design or DevSecOps or those frameworks that can support the improvement of the quality of the software. Yeah, I think that's all from our side.
So, yeah. So if you have any.
Do you have time for questions? If anyone would like to ask now before catching. Yeah.
What products did you use for this on the
You mean the target?
analytics they use to generate
Or to generate?
Both.
Well, this one is Keysight.
Yeah.
It's Keysight. It's a bit transparent to us as a researcher. Keysight separated well from the time that we develop it and the time that someone will implement it in the product. I don't have this visibility, honestly, to say, but I can address to you some contacts from sales people if you are interested. Then you can ask them where this solution is embedded.
products did you use for this?
This is embedded in some product that I have no idea which one it
Yeah,
is.
we develop by ourselves.
We develop it in
Exactly.
It's a
And,
research.
and later the implementation team implements in other products. We are researching and
Yeah.
we are
they
separated.
separate. Yeah,
Exactly.
exactly. Yeah, it is true. From 10 out, 8 out of 10 has at least one vulnerability.
Splittable?
All of them.
All of
are
them?
exploitable. Because we find the issue and then we confirm the issue, exploiting the problem.
Did you notify Qualcomm or like vendors about this?
Yes.
Yeah. You did, okay. Yeah. Similar what we've done in Rapid 7. Well, it's a bit different. They deliberately bought devices, hacked them, and then notified the supplier or the vendor about the vulnerabilities. And if there was no answer received within, I think, 60 days, they would publish this vulnerability. So, unsurprisingly, many vendors did not respond at all.
Yeah.
Including, I know they were hacking Philips baby monitors, and Philips did not really approach the problem. So we got a bit of a backlash. Yeah. It's interesting. Okay, well, we were spot on time. Thank you again. Thanks a lot.
So much.
One question, please.
Yeah, oh, sorry.
So what kind of device did you use there? Is it ILC catcher or what? For your
IMC catcher is one of the attacks that we can reproduce with our scenario. So it will be basically the downgrade attack. We downgrade it to 4G and then we do the IMC catcher. But if I understood your question is more in terms of which kind of attacks we have possibility to reproduce with that.
Yeah.
Downgrade attack is one of them for sure.
and on top of it, like because of this SIM that that we have been using, they come with AGA, authenticated key agreement protocol.
Yeah.
So did you do like some work on that also?
Well, mainly the problems that we found is are more some before the authentication in the RC setup and all those things before the authentication layer or the authentication step or yes transition. We found the most of the problem. But the purpose of this is not to attack the key. The purpose of this is to attack the UE to move to a wrong state, to crash or to get some information from the modem itself, but not attack the keys, not in this AKA or procedure or what any other key interchange.
Great.
Thank you.
Thank you, guys. Now we're moving on to our last presentation before a coffee break. So we have Professor Andreiken from VUB,